we're going to talk about molarity. Molarity is a concentration measurement used to show the relationship of moles to volume in a solution. Molarity, which we abbreviate with a big M, is calculated by dividing the moles of solute by the liters of solution. Well, what's a solute and what's a solution? A solute is the substance that's dissolved in a solvent to make a solution. So the moles of solute is the moles of the substance that's being dissolved, and the liters of solution is the liters of solution that is made when the solute is dissolved into the solvent. Calculate the molarity of each of the following solutions. 2.60 moles of CaCl2 in 1.115 liters of solution. We've said molarity is equal to moles of solute over liters of solution, so we take our 2.6 moles of solute, which is CaCl2, and we divide it by our 1.15 liters of solution. Molarity is equal to 2.60 mole divided by 1.15 liters, and we call this a 2.26 molar solution, and we use 2.26 m to say 2.26 molar. Let's try another problem. 6.631 grams of NaNO3 in 100 milliliters of solution. Now, since molarity is equal to moles of solute divided by liters of solution, we have to convert our 6.631 grams of NaNO3 to moles of NaNO3, and since we have a volume in milliliters, 100 milliliters, we must convert our 100 milliliters to liters in order to calculate molarity. 6.631 grams of NaNO3 divided by 84.994 grams per mole is equal to 0.078 moles of NaNO3. So we've converted our mass of NaNO3 to moles of NaNO3, which satisfies our moles of solute. And now we have to convert our 100.0 milliliters of solution to liters of solution. We do this by dividing 100 milliliters by 1,000 to get 0.1000 liters. Now we can plug in our moles of solute and liters of solution to calculate molarity. Molarity is equal to 0.078 moles of solute divided by 0.1000 liters of solution, and that gives us a 0.780 molar solution. How much solute is required to prepare each of the following solutions? Moles of NaOH for 1.25 liters of a 0.0235 molar solution. So the question is asking, how many moles of NaOH do we need to make a 0.0235 molar solution in 1.25 liters? If we look at our molarity equation, molarity is equal to moles of solute divided by liters of solution. We can rearrange this to read molarity times liters of solution is equal to moles of solute. So if we're looking for our moles of solute, we simply just need to multiply our molarity times our liters of solution. So we're going to multiply our molarity, which is given 0.0235 molar, and our liters of solution, which is 1.25 liters. We do that. 1.25 times 0.0235 gives us 0.0294 moles of NaOH. How many grams of KMnO4 is required to make a 0.01 molar solution in 20.0 milliliters? Again, we're going to use this same equation. Molarity times liters of solution gives us moles of solute. All we have to do is add another extra step to convert from moles of solute to grams of solute. Now if we notice here, our volume given is in 20.0 milliliters. We need to convert this to liters. We do this by dividing by 1,000 to get 0.0200 liters. Now we can plug in 0.0200 liters times 0.0100 molar, which is given, is equal to 0.0002 moles of KMnO4. Now, since we need to find grams of KMnO4, we simply multiply our moles of KMnO4 by its molar mass of 158.032 grams per mole to get 0.0316 grams of KMnO4. How many milliliters of a 0.215 molar solution are required to contain 0.0867 moles of NaBr? So if we have a solution that has 0.0867 moles of NaBr, that is also 0.215 molar of NaBr, how many milliliters must this solution be? If we look at our molarity equation, we can once again rearrange it again to read liters of solution is equal to moles of solute divided by molarity. So we simply need to take our moles of solute, which we have 0.0867 moles, and divide it by our molarity, which is also given 0.215 molar. We'll get our liters of solution, but we just need to add our extra step to convert it from liters to milliliters. So 0.086 moles of NaBr divided by 0.215 molar gives us 0.403 liters of solution. Since we're asked for milliliters of solution, we simply multiply our liters by 1,000 to get 403 milliliters of solution. Next, we're going to talk about dilution. Dilution is changing the concentration of a solution or using one solution to form a new solution of different concentration. The equation we're going to use for dilution problems is M1V1 equals M2V2. What does this mean? In the dilution problem, we're going to start off with an original solution and end up with a new solution. So we have an original solution and a new solution. The original solution has molarity 1 and volume 1. The new solution has molarity 2 and volume 2. So M1 is the molarity of the original solution, V1 is the volume of the original solution, M2 is the molarity of the new solution, and V2 is the volume of the new solution. Important to remember is V1 and V2 must be in the same units. V1 and V2 can either be both milliliters, liters, centimeters cubed, any volume unit, but they must be the same. Let's look at an example. If 14.00 milliliters of 1.04 molar Na2CO3 is diluted to 0.500 liters, what is the molarity of Na2CO3 in the diluted solution? Right off the bat, we see 14.00 milliliters and 0.500 liters. We need to keep our volumes in the same units. So we either need to convert 14 milliliters to liters or 0.500 liters to milliliters. I'm going to choose to convert our 0.500 liters to 500 milliliters. Now we can set up our M1V1 equals M2V2. M1 is the original molarity of the solution. We start off with a 1.04 molar solution. V1 is our original volume. We have an original volume of 14.00 milliliters. This volume is diluted to a molarity 2, which we don't know yet, which we're going to solve for, and a V2, which is given as 500 milliliters, which we just converted from 0.500 liters. So we set up our M1V1 equals M2V2 by plugging in all the variables. 1.04 molar times 14.00 0.00 milliliters is equal to molarity 2 times 500 milliliters. Solving for M2, we get 0.029 molar. How many milliliters of 6.052 molar HCl are required to make 2.00 liters of 0.500 molar HCl solution? We're going to convert 2.00 liters to 2,000 milliliters because the problem asks us for milliliters. If we convert our 2 liters to milliliters, we won't have to do any conversions at the end. If we use 2,000 milliliters, we'll get our answer in milliliters. M1 is the original molarity, which is 6.052 molar HCl. Volume 1 is unknown. We want to know how many milliliters of the original 6.052 molar HCl solution are required to make 2 liters of the 0.500 molar HCl solution. Our molarity 2 is the molarity of the new solution. That's given as 0.500 molar. V2 is the new volume, which we've converted in milliliters to 2,000 milliliters. Plugging everything in, 6.052 molar times V1 is equal to 0.500 molar times 2,000 milliliters. Solving for V1, we get V1 is equal to 165 milliliters. Now, we could have left our 2 liters as 2 liters and solved for a volume in liters and then converted to milliliters in the end, but I chose to convert liters to milliliters in the beginning, so we got our milliliters answer once we solved M1 V1 equals M2 V2. All in all, V1 is equal to 165 milliliters. Next, we're going to talk about ionic concentrations. Molarity is stoichiometrically related. What does this mean? Let's say we have a solution that is 0.647 molar lithium nitrate, LiNO3. We know from before that lithium nitrate, LiNO3, is composed from lithium plus, Li plus, and NO3 minus. What if we wanted to ask, what is the molarity of lithium plus, or Li plus? We would say the molarity of lithium plus, Li plus, is 0.647 molar lithium plus. We know this because there is 1 mole of lithium ions per mole of the ionic compound LiNO3. Therefore, the molarity of lithium plus is simply the same as the molarity as LiNO3, which is 0.647 molar. If we were asked what is the molarity of NO3 minus, or nitrate ions, we would also say 0.647 molar, because there is 1 mole of NO3 ions per mole of ionic compound LiNO3. Let's look at if we had 0.035 molar CaI2. CaI2 is made from Ca2 plus and 2 ions of I minus. What is the molarity of Ca2 plus? Since there is 1 mole of Ca2 plus per mole of CaI2, we say the molarity of Ca2 plus is the same as the molarity of CaI2, 0.035 molar. However, if we were asked, what is the molarity of I minus? Since there are 2 moles of iodide ions per mole of CaI2, the molarity of I minus is double the molarity of 0.035 molar, or 0.035 molar times 2, or 0.070 molar. So the molarity of iodine ions is doubled because there are 2 moles of iodine ions per mole of CaI2. If we had 1.07 molar Al2SO43, we know that Al2SO43 is made from 2 Al3 plus ions and 3 SO4 2 minus ions. If we were asked what is the molarity of Al3 plus, since there are 2 moles of aluminum ions per mole of Al2SO43, we know that the molarity of aluminum ions is double the molarity of Al2SO43. 1.07 times 2 is equal to 2.14 molar. What is the molarity of SO4 2 minus, or sulfate ions? Since we have 3 moles of SO4 2 minus ions per mole of Al2SO43, the molarity is triple that of 1.07 molar Al2SO43. 1.07 times 3 is 3.21 molar. If we had 0.2 molar Fe NH42 SO42, we know that this compound is made from 1 Fe2 plus ion, 2 NH4 plus ions, and 2 SO4 2 minus ions. What is the molarity of Fe2 plus? Since there is 1 mole of Fe2 plus per mole of this compound, the molarity is the same as the compound, 0.20 molar. What is the molarity of NH4 plus? There are 2 moles of NH4 plus per mole of the compound, so the molarity is double that of 0.2 molar, or 0.40 molar. What is the molarity of SO4 2 minus? Since there are also 2 moles of SO4 ions per mole of the compound, the molarity is also doubled to 0.40 molar. If we were given a problem that stated what volume of 0.025 molar MgCl2 should be diluted to 250 milliliters to obtain a solution with a Cl- concentration of 0.0135 molar. How would we solve this? This time we're combining a dilution problem with an ionic concentration problem. So we're going to take the steps of the dilution problems that we solved before, but also take into account the concentrations of the Cl- ion and how it's stoichiometrically related between MgCl2. We know when we have any dilution problem, we're going to use M1V1 equal to M2V2. M1 and M2 are Cl- concentration in this case. Since the problem states a Cl- concentration, M1 and M2 are not the molarity of MgCl2, they're the molarity of Cl-, or the concentration of Cl-. M1, or the original molarity of Cl-, is equal to 0.025 molar times 2, or 0.05 molar. Why is that? Since there are 2 moles of Cl- ion per mole of MgCl2, we double the molarity of the MgCl2 to get the concentration of Cl-. V1 is unknown. Since we're asked for what volume of the original 0.025 molar MgCl2 solution, we don't know it, so we're going to solve for that. M2 is 0.0135 molar. We don't need to do anything to that because it already states that that number is a concentration of Cl- in the new solution. So simply M2 is the given 0.0135 molar. V2 is 250 milliliters. That is also the same as the given. And since we're using 250 milliliters, we know that our volume 1 that we solve for is also going to be in milliliters. Plugging in, 0.050 molar times V1 is equal to 0.0135 molar times 250 milliliters. Solving for V1, we get V1 is equal to 67.5 milliliters.